Hello students. In last lecture we have discussed about concept of velocity and speed. In today's lecture we are going to understand some of the terms which is related to acceleration, what is called acceleration, what is called retardation, and some normal sums related to it. Okay, so let's start with acceleration. Okay, now what is called acceleration? Acceleration, if we want to write its definition in one sentence, we can write that acceleration is rate of change of velocity. Okay, now let's try to understand that what does this mean, rate of change of velocity. First, see here, it is the change of velocity, means when any of object it change its velocity, so in such case we can consider that what is acceleration. For that we have to assume like this, that there is one object and its initial velocity, if the object has the initial velocity of u, we are taking unit in meter per second. So if any of object having initial velocity u meter per second, and after time t seconds it reaches to the final velocity, that we will consider as v meter per second. Now just try to understand that here the initial velocity was u, and after time t the velocity reaches to v meter per second. Okay, according to this, that acceleration is rate of change of velocity. So let us find first change of velocity. So what do we mean by change of velocity? Here we can write like this, that change of velocity delta v is equal to how much change is done in velocity. Initially it was u meter per second, after t time it becomes v meter per second. So change in velocity, it will be considered as final velocity minus initial velocity. Now what is our final velocity? Our final velocity is v, and our initial velocity it is u. So here delta v will be equal to v minus u. Suppose we take this as equation number 1. Now again get back to the definition of acceleration, rate of change of velocity, or we can also call it that change in velocity in unit time, that will be considered as rate of change of velocity, and that is only equal to acceleration. Now suppose if I note this acceleration as a, so what we can write? We can write like this, acceleration a is equal to change in velocity, so delta v, upon in unit time, so delta t, or t, time taken t. Now delta v from this first equation, what we are getting? We are getting it as v minus u upon the total time. At initially it was at 0 second, and after time t it will be t. So v minus u divided by t. That means acceleration is equal to v minus u divided by t. So this will be our formula of acceleration. Now how we can derive its unit? What will be unit of acceleration? Simple, here we have seen that it is also delta v by delta t. So unit of v means velocity. For units we can write it like this. Here we will have unit of velocity upon unit of time. Now what is unit of velocity? It is meter per second, and unit of time, it will be second. So we will get here meter per second square. So unit of velocity will be meter per second square. Again, what is called acceleration? Acceleration means rate of change of velocity. For that we have to consider one object. Its initial velocity is u meter per second. After time t, it reaches to its final velocity v meter per second. Change in velocity delta v will be final velocity minus initial velocity. Our final velocity was v, initial velocity is u, so delta v is equal to, we will get v minus u. Change in velocity in unit time, and that is also equal to rate of change of velocity. Means here we can see that velocity is changed with respect to time, and that is also considered rate of change of velocity. And here we have seen that rate of change of velocity is called acceleration, and we are noting that acceleration as non-capital A. So from that, what formula we can derive? We can derive that A is equal to delta v by delta t, means it is change in velocity with respect to time, or rate of change of velocity. But delta v will be equal to v minus u according to first equation. So here we are writing v minus u divided by t. So from that, what formula we will get? We will get A is equal to v minus u divided by t. How we can write its unit? Here it is velocity, so here we will have unit of velocity, divide by, here it is time, so we will have unit of time. So unit of velocity, it is meter per second, unit of time, that is second. So here we will get unit of acceleration, meter per second square. Okay, so as we have declared that change in velocity will give us acceleration. From that, acceleration A is equal to v minus u divided by t. Now there are two possibilities. The first possibility is that initially the velocity means u, and final when it reaches to the velocity v. Sometimes the initial velocity will be more, okay, and sometimes the final velocity is more. Like, just take one example. Suppose a train starts its motion, okay, so suppose it starts its motion from 0, and after t time it reaches to particular velocity v. So in such case, what is going to happen? The initial velocity was 0 and it reaches, it suddenly exponentially increases to velocity v. Okay, so in such cases our initial velocity is less in comparison to final velocity. But suppose if any of car or if any of train is moving with some velocity, and if we apply brake on it, so what will happen? The final velocity will get decreased. In short, we can say that in term of velocity, either velocity can increase or velocity can decrease. In this case, our velocity, here you can see that u is small and v is big. So here in this case our velocity increases, and in this case our velocity decreases. Okay, now try to understand here. If we check this formula, A is equal to v minus u divided by t. If our v is more, so answer of A in this case, answer of A, if v is more, so the bigger number minus smaller number, so always this will be positive and time is always positive. So in this case our acceleration will be always positive. But if we talk about this case, in this case our acceleration, it is going to be negative. Why it is going to be negative? Because here you can see that u is bigger, so small number minus big number, so our answer will be negative of our numerator. Denominator is positive, so if the numerator is negative and denominator is positive, then also the whole answer will be negative. So in such case the acceleration is negative. So what we can say here, acceleration, it is a vector quantity, and vector quantity requires direction and magnitude both. So we can easily find out the magnitude but for direction, what we can say, if the direction is positive, that means there is increasing velocity. But if our answer is negative, that means there is decreasing velocity, and this decreasing velocity, it is also called retardation. So the negative acceleration, again the negative acceleration, it is called retardation. Here you can see that the negative acceleration, in this case when your velocity get decreases, a will be negative. So if a is negative, so we can also call it as retardation. So what will be definition of retardation? We can say that retardation means during a accelerated motion, if the velocity is decreases, it will result into retardation. Now what is difference between acceleration and retardation? Both are similar, both are change in velocity with respect to time, but in retardation always velocity is going to get decreased. Now let us understand some of the easiest sum and the basic sum related to acceleration. Here we are having one question. See, starting from a stationary position, so in that case we can see that our velocity, it will be 0. Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. So keep this in our mind. Okay, and initially it was as stationary position. Then he applies brake and the velocity, it goes to 4 meter per second in 5 seconds. What we have to do, we have to calculate the acceleration of the bicycle in both of the case. So first of all, understand here which two cases are there. First it is at stationary, then Rahul applies pedal and starts its acceleration. So that is our first case, in which it was at stationary and it starts its acceleration. Okay, in second case it was at constant speed of 6 meter per second and he applies brake and it reduces its velocity to 4 meter per second. So how we can calculate it? So let's see from the question. Case 1, first of all understand the phenomena. Here it is at 0, it starts its velocity, and here it attains its velocity 6 meter per second. For that it takes 30 seconds. Then he applies brake and have 4 meter per second in next 5 second time. Okay, so from the question we are getting this much, that it is at stationary. After 30 seconds while pedaling, it will increase its velocity to 6 meter per second. As it is moving with 6 meter per second, then he apply brake and in 5 seconds it reduce its velocity to 4 meter per second. Now you are very clear that here we will get acceleration positive because the velocity is increasing, and here you will get it negative means the acceleration will get here negative. We can also call it as retardation. Now let's calculate. In first case, our initial velocity u, what it will be? Initially it is stationary, so we will get it as 0. Here this is our first case, so it attains 6 meter per second, so that will be our final velocity of 6 meter per second. For that, how much time it is taking? It is taking 30 seconds, so t is equal to 30 seconds. Okay, now see, for that we have to find out acceleration. Formula of acceleration: a is equal to v minus u upon t. What is our v? It is 6. Initially it was stationary, so we will get 0, and for that how much time we are taking? We are taking 30 seconds. So answer will be 6 by 30, which will be resulted into 0.2 meter per second square, unit of acceleration, meter per second square. Okay, now in that only our second case, case 2. What happens in case 2? This was our case 1, from 0 to 6. In case 2, it is at 6 meter per second of velocity, and it applies the brake and it attains 4 meter per second in next 5 seconds. So this will be our initial velocity in case 2, because this was initial in case 1 and this was final in case 1. So as he apply brake, so at that time whatever the velocity will be, that will be our initial velocity for second case. So our initial velocity will be 6 meter per second, and final at last it will give us 4 meter per second, and it is taking 5 seconds of time for it. So in this case, let's find the velocity. Let's find the acceleration. Acceleration a is equal to v minus u divided by t. V, that is 4, minus u, that is 6, divided by t, so that will be 5. We will get here minus 2 by 5, which will be equal to minus 0.4 meter per second square. Meter per second square is unit of acceleration. Again, here our answer will be minus, because here you can see that velocity was decreased, so our acceleration will be negative. So for this particular sum, we can say that the acceleration of the bicycle in the case 1 is equal to 0.2 meter per second square, and in case 2 it will be minus 0.4 meter per second square. We can also call that in case 2 we are getting retardation.